27 raised to power x square minus 9 raised to power x square is equal to 3 raised to power x square. What is the value of x? Solution. (27 raised to power x square can be written as 3 raised to power 3 raised to power x square minus 9 raised to power x square can be written as 3 square raised to power x square is equal to 3 raised to power x square. Then take note of this rule that if you have a raised to power n to the power of m, this is equal to a raised to power m to the power of n. This is equal to a raised to power n m. So we have 3 raised to power x square to the power of 3 minus 3 raised to power x square to the power of 2 is equal to 3 raised to power x square. Let 3 raised to power x square is equal to y. Then we have y raised to power 3 minus y square is equal to y. This is y raised to power 3 minus y square minus y is equal to 0. Now, y is common. Let's factor it out. Y bracket y square minus y minus 1 is equal to 0. There are two cases here. First case is y is equal to 0, or second case y square minus y minus 1 is equal to 0. So from here we have y is equal to 0. Now let's work with this. This is a quadratic equation which can be solved using quadratic general formula. And a quadratic general formula in this case is giving us y is equal to minus b plus or minus square root of b square minus 4ac over 2a, where a is equal to 1, b is equal to minus 1, c is equal to minus 1, y is equal to minus bracket minus 1 plus or minus square root of minus 1 square minus 4 multiplied by 1 multiplied by minus 1, everything over 2 multiplied by 1. Y is equal to 1 plus or minus square root of minus 1 square is 1 plus minus 4 times minus 1, that is plus 4 over 2. Y is equal to 1 plus or minus square root of 5 over 2. Y is equal to 1 plus or minus square root of 5 over 2. Therefore, y is equal to 1 plus square root of 5 over 2, or y is equal to 1 minus square root of 5 over 2. Now, but 3 raised to the power x square is equal to y. Then we have 3 raised to the power x square is equal to 0 from the first case, or 3 raised to the power x square is equal to 1 minus square root of 5 over 2 or 3 raised to the power square is equal to 1 plus square root of 5 over 2. But from here, 3 raised to the power square cannot be 0. This is not valid. So 3 raised to the power square is equal to 1 minus square root of 5 over 2. This is less than 0. It's also not a real solution. Then the only real solution we have is 3 raised to the power square is equal to 1 plus square root of 5 over 2. Then let's work with this. We have 3 to the power of square is equal to 1 plus square root of 5 over 2. Let's take the log of both sides. Log 3 raised to the power square is equal to log 1 plus square root of 5 over 2. S square log 3 is equal to log 1 plus square root of 5 over 2. Now let's divide both sides by log 3. Log 3 is divided by log 3. Then this one will cancel this. S square is equal to log 1 plus root 5 over 2 all over log 3. S is not equal to plus or minus square root of log 1 plus root 5 over 2 all over log 3. Now, S is equal to plus or minus square root of log 1 plus root 5 is divided by 2 is 1.6180 over log 3. S is now equal to plus or minus 0.6618. This is the final answer. We can check to confirm if our answer is right or wrong. Let's check. We have the given equation. 27 raised to the power square minus 9 raised to the power square is equal to 3 raised to the power square. Now, when s is equal to 0.6618, we have 27 raised to the power 0.6618 square minus 9 raised to the power 0.6618 square must be equal to 3 raised to the power 0.6618 square. And this is 27 raised to the power 0.438 minus 9 raised to the power 0.438 is equal to 3 raised to the power 0.438. Then, and for this, 3 raised to the power 0.438 is equal to 1.618. Therefore, 27 raised to the power 0.438 minus 9 raised to the power 0.438 is equal to 1.618 is equal to 1.618. We satisfy the given equation at S is equal to plus or minus 0.6618.